Alright guys, we're going to start looking at exponential functions today. Exponential functions. So we have two types of exponential functions. We have a growth function, which would be increasing over your x values, and we have a decay function, which is going to be decreasing over your x values. So let's get right into it. Let's look at the parent functions for our growth and our decay exponential function. So this is what we call the parent function for a growth function. Okay, as you can see, it's an increasing function. The intercept is going to be right here at 0, 1. Okay, we're going to rewrite this. I'm going to rewrite this in the form f of x equals 1 times 2 raised to the x. Alright, and now the reason I'm doing that is because this 1 right here, this is the a value. This is the b value, or the base, we could say. And then we have x, and then we have minus h plus k. Okay, so my parent general form right here is a times b x minus h plus k, which is what I'm doing right here. In this case, we have base of 2, which is my parent base. Okay, we have 1 right here for a. It's just not written. We don't have anything 0 for h, and we don't have anything for k. So 0, 0 is h and k. So initially, we're starting at the origin. We did not move the graph any. Okay, this would be 1 would be my initial value, which would be up 1 unit. Okay, and then my base of 2. It's a growth function. The reason it's a growth function is because my base is greater than 1. So it's a growth function if base is greater than 1. It's a decay function if your base is less than 1. So in this case, my base is 1/2. Right? So it's a decay function. Now you can see as a decay function, as I am increasing in my x values, my function is decreasing, right? So as the graph is moving from left to right, my function is going down. So that is what we call a decay function. Now, two important things here. You can see that it does not cross the y-axis, right? So we have a asymptote right here at y equals 0. Same thing for the decay function. We still have an asymptote at y equals 0. Okay, we cannot have a negative value for y. Cannot have a negative value for y in my base parent functions. Now, obviously, we can have reflections that will make negative y values, but you know what I'm saying. Domain negative infinity to infinity for both of these functions. The range is going to go from your asymptote to infinity, okay, unless we have obviously a reflection. All right, so let's look at identifying growth and decay functions. So it says identify if it's a growth or a decay. In this case, my base is greater than 1, so this would be a growth. Decay, because I have a 2/3 as my base, and then 7/4 is a growth. So notice that this number in front, this 0.4, excuse me, or this 7 or this 5 had nothing to do with it. All I'm looking at is the base. Those numbers in front, the a values, is going to be a vertical stretch or a vertical compression. Right? So if a, right here, I'm looking at this number in front of the base. If a is greater than 1, it's a vertical stretch. If a is less than 1, it's a vertical compression. Right? So we have h of k, and that again is my starting point. Okay, so right here, h of k is 0, so my starting point is at the origin. Now the next, the natural exponential function. Okay, we have a e, okay, that's used to denote an irrational number. Okay, we'll get into more of this later, but e is approximately 2.7-ish. It's a very long decimal. Okay, and we'll get into why I get e later. But again, the function is defined by this. So this is the natural exponential function. Okay, you can see here e raised to the x. All right, now it says, does it represent a growth or a decay? Well, e is equivalent to about 2.7. Okay, so 2.7 as my base would indicate that this is a growth function. It's a growth function. All right, so let's look at how to graph these puppies. Looking at this equation right here, I've got 2, which is the base. I've got an h value of -1, and I've got a k value of -4. Okay, so you can see that we went down 4 units, and we went over 1 unit. So this was our initial starting point. Now I'm going to rewrite this as f of x equals 1 times 1 times 2x plus 1 minus 4. Now you can see here that the a is 1, right? So no vertical stretches or compressions, which means we're going to go up 1 from my starting point, and we're going to have a point right there. My base is 2, so right there, that's the parent base. I've got left 1 unit, okay, and I went down 4. So you can see my range goes from the horizontal asymptote to infinity because this is a growth function. My domain is all real numbers. So looking at number 1, I have 2 raised to the x plus 4 minus 8. So this is a growth function because my base is greater than 1. H and k, h is going to be negative 4, k is going to be negative 8. So what that's telling me is that my asymptote is going to be at y equals negative 8. Now let's identify our transformations, right? So we have left 4 units and we went down 8. Domain is going to be all real numbers, or negative infinity to infinity. Okay, this is a growth function, so the range will be from my asymptote, my horizontal asymptote to infinity. All right, now it's important to note that it does not include your horizontal asymptote, so it's a parentheses right there, and it's going to go to infinity. All right, and then my y-intercept. Okay, as you can see, all I have to do is plug in 0, so I've got 2 raised to the 4th minus 8. 2 raised to the 4th is 16. 16 minus 8 is 8, so I have the y-intercept at 0, 8. So the y-intercept is at 0, 8. Okay, I went left 4 down 8, so left 4 down 8. So my initial starting point is right here. I have a base of 2, so we have a point right there. So my graph will look something like this. All right, looking at number 2. Number 2 is a decay function because my base is less than 1. So we have a decay function. Okay, h is going to be positive 1 because it's x minus h, so positive 1, positive 6. So we're going to go right 1 unit. We're going to go down, up 6. So my asymptote, my horizontal asymptote, is at positive 6. So we know right now that it is a decay function. Okay, so it's still going to be above my asymptote. It's just going to be decreasing. So my domain is still going to be negative infinity to infinity, or all real numbers. Okay, but it's going to be a decreasing function. So my range is going to be from my horizontal asymptote, which is at 6, to infinity. All right, so transformations, we went right 1. We went up 6. Now the y-intercept, we're going to plug in 0 right here. So I have 1/2 raised to the negative 1 plus 6. Anytime you have a negative exponent, all you got to do is take the reciprocal, right? So 1/2, the reciprocal of that is 2 plus 6. So I have a y-intercept at 0, 8. There's my decay function. All right, looking at number 3. Now, number 3, you can see I have a base of 10. Right, I have a base of 10. Okay, I have an a value of negative 2. Right, so this is a transformation. This is a transformation. This is a transformation. That's a transformation. All right, so base 10. Well, the base is greater than 1, so it's still a growth function. My h value is negative 1 because it's a plus 1 here. K value is negative 7. So you can see we went left 1. We went down 7. What else changed? We had a reflection over the x-axis with that negative in front, and we had a vertical stretch by 2. Alright, so let's look at my domain. Domain is negative infinity to infinity. The asymptote, we went down 7 units, so the asymptote is going to be at y equals negative 7. Oops, sorry. So let's graph our asymptote. Bam, right there. Okay, now we know that a growth function and a decay function were above my asymptote. Now we're going to have a reflection that's going to be over the x-axis, okay, or quote unquote over the asymptote. So now it's going to be down here, right? So this is going to look like this. So instead of going up, it's going to go down, right? It's going to reflect over the x-axis. All right, so the range is going to be from negative infinity to now my asymptote, which is at negative 7. Okay, my y-intercept, if I plug in 0 here, I've got 10 raised to the 1, which is 10, times negative 2, which is negative 20, and minus 7 is negative 27. So 0, negative 27. So you can see that it's way down here. All right, so now we went left 1, we went down 7, so my initial point is right there. Okay, now my A is negative 2, so instead of going 1 unit away from that, we're going to go 2 units away from that. We have a point right here. So my graph looks something like that. Can't plot the y-intercept, that's going to be at 0, negative 27. Looking at number 4, we have the natural exponential function, e raised to the x plus 4. So this is my base function. We only had one transformation here. It's a growth function because e is about 2.17. Okay, so h and k are still 0, 0, because we didn't move the graph right or left any. Sorry, k is not 0, k is 4. So right here is 0, k is 4. Transformations, all we did was go up 4 units. Domain is going to be all real numbers. We went up 4 units, so my horizontal asymptote is going to be at 4. So my range is going to be from the asymptote to infinity, because we didn't have any reflection, so it's going to be above my asymptote. My asymptote is going to be at y equals 5. Okay, and my y-intercept is going to be at 0, 5. Plug in 0 here, we get 1 plus 4. Okay, anything raised to 0 power is 1, right? So 1 plus 4 is 5. So we have the y-intercept at 0, 5. Bam, there it is. Let's graph our function. Easy breezy.